but it's flexible enough to be turned into any shape.
However, once it's been submerged in water and given time to set, it becomes completely solid.
The Chinese president couldn't believe his eyes when he saw a new construction technique that seemed almost impossible. From inflatable concrete domes that rose like giant air-filled sculptures to self-healing bridges that mended their cracks, these construction methods have defied the limits of speed and skill. Join us as we uncover 15 mind-blowing construction techniques. Number 15. SELF Healing Concrete. Self-healing concrete feels almost magical, yet it is built on a very simple idea: tiny living helpers mixed directly into the cement. Inside this special concrete, there are bacteria resting quietly, waiting for the perfect moment to wake up. They stay asleep for a very long time, protected by small capsules scattered throughout the structure. Nothing happens until the concrete cracks. When that crack appears, water slips inside and reaches the hidden bacteria. The moment moisture touches them, they come alive. Once awake, they begin an incredible process. They feed on the nutrients sealed with them and start producing limestone. This limestone slowly fills the crack from the inside out, closing the space, just as if the concrete were healing itself. Over time, the damage becomes almost invisible, and the structure regains much of its strength. This ability makes the concrete especially useful in places that are hard to reach, such as old tunnels, remote bridges, and large water tanks that are rarely checked. In these places, small cracks can grow silently and lead to major problems. Self-healing concrete protects against that danger. It reduces the chances of surprise failures and gives structures a longer, steadier life. Imagine a bridge in a distant area, far from daily inspection. Instead of waiting for someone to find a crack, the concrete fixes the problem before it spreads. This means fewer repairs, less cost, and far more safety. In the future, this kind of concrete may become common everywhere, bringing peace of mind to engineers and communities. With every healed crack, it proves that even strong materials can become smarter, not just tougher. Something extraordinary is rising upward, not by human hands alone, but by climbing itself skyward. Number 14. The crawling tower slipform construction is one of the most fascinating building methods of modern engineering. At its heart lies a simple yet powerful idea created by James McDonald. He imagined a structure that could rise without stopping, lifting itself slowly as workers poured fresh concrete below it. Instead of building in separate levels, the entire system would move upward like a living machine. Slipform works through a tall framework that holds the formwork for the walls. This formwork does not stay still. It crawls upward, powered by jacks that lift the whole assembly a little at a time. As the concrete is poured, the formwork rises just enough to let the material set while still keeping its shape. Slowly, the tower grows higher. The movement is steady, almost like a steel caterpillar inching its way toward the sky. One of the biggest advantages of this method is speed. Since the structure rises without pause, there is no waiting for each level to cure before starting the next. This continuous process makes it perfect for tall shafts, silos, and strong vertical walls that need to be completed quickly. It also reduces the amount of scaffolding and lowers the risk of delays, especially in projects where time is critical. However, slipform construction comes with certain limits. It requires careful planning, skilled workers, and constant monitoring. Once the climb begins, it cannot be stopped easily. Any mistake can travel upward with the form. But when handled well, the results are beautiful: smooth, strong walls, and evenly shaped towers. Compared to climbing formwork, which moves in stages, slipform is far more fluid. Climbing formwork lifts in steps and pauses between cycles. Slipform climbs without resting. The difference is simple but powerful, making slipform feel alive as it pushes a structure toward the sky, one slow movement at a time. From the warmth of rising concrete, we travel into the chill of space materials that now protect modern homes. Number 13. The feather-light shield that stops heat aerogel looks delicate, almost like a piece of frozen smoke, yet it has one of the strongest insulating powers on Earth. It began as a thermal protection material used by NASA, guarding spacecraft from extreme temperatures. Today, this spaceborne invention has found a new home in ordinary buildings, changing the way houses are kept warm and cool. What makes aerogel special is the way it holds air. It traps countless tiny pockets inside its structure, slowing heat almost to a stop. A small sheet of aerogel can do the work of a thick wall of traditional insulation. This makes it especially useful for modern homes where space is precious. Walls can stay thin while still providing excellent comfort. The result is a home that feels cozy without needing heavy layers. One popular demonstration helped people understand aerogel's power: the fire and chocolate test. A piece of chocolate is placed under a thin layer of aerogel. A flame is applied above it, yet the chocolate stays solid, untouched by the heat. The message is simple and unforgettable. If a fragile sweet can stay safe under fire, then a building wrapped in aerogel can stay comfortable even in harsh weather. Beyond thermal insulation, aerogel also has acoustic benefits. It slows down sound waves just as well as heat, creating quieter rooms and calmer spaces. This makes it valuable in busy cities, where noise often follows people indoors. Houses built with aerogel feel peaceful, even when the world outside is loud. Its lightweight, fire resistance, and powerful insulation make aerogel one of the most exciting additions to modern construction. It carries a piece of space technology into everyday life, turning homes into efficient, protected shelters. But what if the walls of the future are not made, but grown? Number 12. Wood that grows into shape. Bioengineered timber offers a bold and beautiful vision for the future of construction. Instead of cutting wood and forcing it into shapes, researchers are discovering ways to guide trees as they grow, shaping them into useful curves and forms. This means wood can grow into the exact structure needed, whether it is a gentle arc, a twisted beam, or a long, steady curve. The result is natural architecture formed by the tree itself. Scientists are studying how to direct the fibers of young trees so that the wood bends naturally as it matures. By adjusting growth conditions, they can coax the trunk or branches to lean in a desired direction. Over time, the wood takes on the shape of an arch, a loop, or a supporting frame. Instead of carving material away, nature does the work from within. Buildings made from this type of timber could one day rise with far less waste. Because the wood is formed by nature, there is no need for heavy machinery to cut, bend, or reshape it. This approach also locks away carbon, making the construction process carbon negative. Every shaped tree becomes a living storehouse for carbon long before it becomes part of a building. The possibilities stretch across entire cities. Imagine neighborhoods where structures grow slowly but surely, prepared years in advance. Arches might rise from living roots, and curved walls might form from trees trained from youth. The idea feels almost like a story from the future, yet researchers are already experimenting with small prototypes. Number 11. Inflatable concrete revolution. The idea of inflatable concrete began with Dante Bini, who dreamed of a building that could rise as simply as filling a balloon. His early designs looked unusual, almost too simple to be real. Yet inside those soft shapes was a powerful method that would change emergency construction forever. It starts quietly. A flat sheet, folded and resting on the ground, begins to swell as air is pumped inside. The structure rises slowly, taking shape in calm movements, almost like a giant lung filling with breath. Beneath the surface lies a steel skeleton waiting to be locked in place. As the form reaches its full shape, workers begin the next step. A fine spray of concrete is released, falling like gentle rain over the inflated mold. Layer by layer, the shell hardens. The once soft surface becomes firm, strong, and ready to face the world. Speed is the heart of this invention. During storms, earthquakes, or sudden crises, people need shelter fast. Traditional building takes time that communities cannot spare. The inflatable method gives them roofs in a matter of hours, not weeks. It brings hope with smooth, rounded walls that stand solid even when the outside world feels unsafe. Many doubted whether a structure created from air could ever rival stone. Yet these domes have surprised experts again and again. They handle heavy winds with ease. Their curved shapes guide storms away instead of fighting them. Communities have watched powerful winds roll across the domes without leaving scars. The mystery lies in their geometry. Their round surfaces spread stress evenly in all directions. Instead of breaking at weak corners, the structure behaves like a single, unified shield. In remote places and disaster zones, these domes rise quickly, last long, and offer strength that seems almost impossible for something born from air. Now, prepare for concrete that does not stay dark at night, but glows like captured daylight. Number 10. The magic of light-emitting. Light-emitting concrete brings a gentle touch of magic to the world of construction. It begins with a simple idea. Let concrete absorb sunlight during the day and release it in a soft, steady glow once darkness arrives. The surface looks plain when the sun is up, yet deep within it, tiny particles gather light and store it carefully, waiting for evening to fall. When night comes, the concrete releases a cool and calming shine that feels almost alive. This glow has become a gift to road safety. Paths, highways, and narrow turns can shine without the need for constant electricity. Drivers gain clearer visibility, and pedestrians move with more confidence. The gentle lighting also reduces energy use, helping communities save money while keeping people safe after sunset. Beyond roads, the beauty of glowing concrete has entered places of worship and art. Mosques use the soft shine to outline patterns, adding peaceful light without harsh brightness. Artists use it to create smooth transitions between day and night in their installations. The material becomes both functional and expressive, carrying meaning through its quiet illumination. One question stands at the center of its future. Can this glowing surface last through the long, hard years that ordinary concrete survives? Engineers test it in heat, rain, and heavy use. So far, the results show promise. The material keeps its glow without fading too quickly, and its strength remains dependable. Still, the challenge of time remains, pushing researchers to improve and test even more. Number 9. The upside-down build, top-down construction, turns the entire building process upside down. Instead of digging deep first and building upward later, this method begins at ground level and moves in both directions at once. It is a bold shift in thinking, yet it has become one of the most valuable tools in crowded cities, where space is scarce and deadlines are tight. It starts with the first ground-level slab. This slab becomes the anchor for everything that follows. Strong columns are pushed deep into the soil beforehand, so they stand ready. Once the first slab is complete, workers begin two tasks at the same time. They build the next floor upward while digging beneath to create the basement levels. As each basement level is uncovered, a slab is poured above it. Each slab locks into place, adding strength and stability. These basement slabs do more than create floors. They act as anchors that keep the surrounding soil steady. In busy cities with narrow streets and tall neighbors, this control is priceless. It prevents the ground from shifting and protects nearby buildings from damage. The method saves time and reduces disruption at street level. Pedestrians and vehicles can continue moving above while the hidden world below takes shape. The city continues breathing normally, even as a new structure grows downward, carving hidden rooms and deep foundations. Yet, this method carries challenges. The coordination must be perfect. Each movement below affects the work above. Engineers feel the pressure of making sure everything stays aligned, balanced, and safe. A small mistake can ripple through the entire structure. Despite these fears, the method continues to spread because it solves problems that traditional methods struggle to face. Top-down construction proves that innovation is not only about rising higher, but also about digging smarter beneath our feet. Now, let's take a look at the huge bridge that moves before it touches the sky. Number 8. The high-risk world of bridge. Bridge launching transforms the way long spans are built. Instead of assembling pieces high above rivers or deep valleys, engineers create major sections on firm ground. This idea was pushed forward by Marco Rosanoli, who believed that building safely on land could save time and reduce danger. Once a section is complete, the structure begins its slow journey forward, sliding inch by inch into open air. At the front of the bridge sits a long, pointed extension known as the launching nose. It is lighter than the main bridge, yet strong enough to guide the entire span across empty space. As the bridge pushes forward, the launching nose touches the far support first, reducing the bending force on the main section. This careful balance allows hundreds of tons to glide across a gap without falling. The sight is breathtaking. Massive steel and concrete move over nothing but air, held only by precision and engineering courage. Every shift must be exact. Every alignment must be perfect. If the direction is even slightly off, the entire span could tilt or twist, causing a collapse. This risk makes each launch feel like a moment suspended between mastery and disaster. Yet the method continues to grow in popularity. It avoids the need for dangerous scaffolding. It reduces work above water. It keeps workers safer by letting them build on solid ground. Countries around the world now use bridge launching to cross wide rivers and deep valleys with speed and confidence. As the bridge slides into place, the tension slowly fades. The structure reaches its final support and settles into position, turning a daring moment into a permanent pathway. What once seemed impossible becomes part of everyday travel, proving that even the heaviest structures can move gracefully when guided by precise hands. Number 7. Buildings that move. Kinetic architecture brings movement into buildings, turning still structures into living forms that shift, unfold, rotate, and breathe with their environment. It is a world where walls glide open, roofs expand like wings, and entire rooms turn to face the sun. Each movement has a purpose. Each motion adds comfort, beauty, or efficiency. Together, they create spaces that feel almost alive. Some museums have taken this magic to a new level. Their walls and roofs unfold like birds opening their wings at dawn. During the day, the wings rise to let in natural light. When the sun grows too strong, the wings lower themselves, giving the art inside a calm, shaded home. These museums change shape from morning to evening, responding to the sky the way living creatures do. In China and Korea, moving facades decorate tall buildings. At first glance, the structures look ordinary, but as the day passes, panels slide, rotate, or shift to control sunlight and reduce heat. These facades act like giant shields, protecting the inside from harsh weather while creating patterns that dance across the surface. The buildings appear to breathe, adapting to each hour with graceful changes. One of the most impressive examples is the Sharifi Ha House, where entire rooms rotate outward. When the weather is pleasant, the rooms turn toward the open air, becoming bright terraces. When winter comes, they retreat inside, forming warm, sheltered spaces. This slow rotation creates a home that reshapes itself for comfort all year long. Still, movement brings tension. What happens if the parts fail? Engineers prepare for this carefully, adding strong motors, sensors, and backup systems so the building stays safe. Even with these safeguards, the question of reliability adds a thrill to every design. Number 6. 3D knitted formwork. 3D knitted formwork blends delicate cloth with heavy concrete to create shapes that once seemed impossible. It begins with industrial knitting machines, weaving soft, lightweight fabric designed not for clothing, but for construction. The result is a custom-made mold that feels almost weightless in your hands. But this simple cloth holds the power to guide concrete into curves, waves, and flowing designs that traditional molds struggle to create. The process starts with a precise knitted pattern. Every loop and stitch is placed with intention, forming a flexible skin that will soon carry enormous weight. Workers stretch the fabric over a frame, giving it the desired outline. Then comes the moment of tension, the pouring. Wet concrete slides into the cloth, heavy and slow, testing the strength of every thread. It seems impossible that fabric could support such weight. Yet, the engineered knit holds steady, shaping the concrete like a sculptor guiding clay. As the material sets, the cloth mold reveals its beauty. The final structure may rise to the size of a small car, or even larger, sometimes weighing as much as 5 tons. The curves feel natural and smooth, formed without the hard edges of traditional molds. Architects love this freedom. They use knitted formwork to bring gentle waves into walls, create sweeping columns, or design pieces that twist softly like ribbons. This method reduces waste because the fabric uses less material than rigid molds. It also allows faster construction since the cloth is easy to transport and set up. The mystery behind its strength lies in the pattern of the knit, which spreads the force evenly and prevents collapse. Through careful engineering, the fabric becomes a quiet partner to concrete, balancing softness and power. Number 5. The art of earth berming. Earth berming transforms simple houses into hidden sanctuaries protected by soil, plants, and the gentle curves of nature. These homes nestle into hillsides or surround themselves with layers of earth that create a natural shield against the world. From the outside, they often look like calm mounds covered in grass and flowers. Inside, they feel warm in winter, cool in summer, and deeply connected to the land. The soil above and around the home acts as powerful insulation. In hot months, the thick covering blocks heat, keeping rooms comfortable without constant cooling. In cold months, the earth holds warmth like a giant blanket, reducing the need for heavy heating. This natural temperature control creates a peaceful, cave-like environment that stays steady no matter how wild the weather becomes. Earth-bermed houses also offer a surprising quietness. The soil acts as a barrier that stops noise before it enters. Busy streets, loud neighbors, and city sounds fade into silence. Inside, only soft echoes remain, creating a sense of calm many people dream of. Beyond their comfort, these homes carry a simple charm that reminds people of fairy tales. Their rounded shapes blend with the landscape, giving them a hobbit-like look that many find enchanting. The roofs may bloom with wildflowers, and the entrances often feel like gateways into secret worlds. Families living in them feel close to nature without losing the safety and strength of modern design. Earth berming also helps the environment by reducing energy use and supporting local ecosystems. Plants grow freely on the roofs and hillsides, inviting birds and insects while strengthening the soil. But soon, walls themselves begin to breathe and grow, producing energy like tiny green factories. Number 4. Algae facades that grow energy algae. Facades bring nature and architecture together in a way that feels both futuristic and beautifully simple. One of the most famous examples is the BIQ house in Germany, where green-tinted panels cover the exterior like living windows. Inside these panels, algae grow rapidly in warm sunlight, filling the walls with color and movement. The bubbling growth inside the facade looks like a gentle living pulse running through the building. These algae are more than decoration. As they grow, they produce heat that can be collected and used inside the building. They also provide shade, reducing how much sunlight enters on hot days. This creates a natural cooling effect, similar to leafy trees. In winter, the algae slow their growth, allowing more sunlight to pass through and warm the rooms. The facade behaves like a set of natural blinds that shift with the seasons without needing human control. The algae also creates fuel. As they multiply, they can be collected and turned into biomass, energy, offering a renewable source of power. This turns the building into a miniature energy farm, using its walls to help power daily life. It is a small step toward buildings that feed themselves rather than rely heavily on outside sources. The environmental impact is hopeful. These facades reduce carbon emissions, support cleaner energy, and bring plant life into cities in a new way. Instead of relying only on rooftop gardens, algae-filled walls use vertical surfaces to support growth and energy production. Algae facades prove that buildings do not need to stay still or silent. They can grow, change, and help the planet, turning city blocks into healthier, greener places. Number 3. Turning desert sand into super bricks. Desert sand stretches across wide lands, soft and dry, beautiful yet nearly useless for building. Its grains are too fine and too smooth to hold together the way river sand does. For decades, engineers struggled with this problem. Huge deserts offered endless sand, yet almost none of it could be used to build homes, roads, or cities. But then came a powerful innovation that promised to change everything. Scientists discovered special binders that could transform this fine sand into incredibly strong bricks. These binders wrap around each grain, locking them together like tiny hands, forming a solid bond. The once loose sand becomes firm blocks that can withstand pressure, heat, and time. These new bricks are called metamorphic sand bricks because they take something soft and reshape it into something tough and dependable. For desert nations, this invention feels like discovering treasure beneath their feet. Instead of importing costly materials, they can produce building blocks from the land around them. Entire communities could rise with local resources, reducing transportation costs and empowering people to build faster and more affordably. This shift could completely change how towns grow in dry regions. There is also an important environmental benefit. River sand has been mined heavily for construction, causing erosion, damaged ecosystems, and disappearing riverbanks. By using desert sand instead, the pressure on rivers is reduced, giving nature a chance to recover. This makes metamorphic bricks not only practical, but also gentle on the planet. Yet one thrilling question lingers. Could whole cities someday rise from dunes? The idea feels like a dream. Streets, schools, and towers shaped from the very land they stand on. Scientists work carefully to test the strength and long-term behavior of these bricks. If they continue to show promise, the deserts of the world may become the foundation of future civilizations. Now let's take a look at the machine that can print a house like a giant humming artist. Number 2. The rise of 3D concrete printing. 3D concrete printing has changed the way people imagine building homes. Instead of dozens of workers stacking bricks or shaping wood, a huge robotic printer glides across a site, releasing smooth layers of concrete. The process looks almost like icing a cake, except the layers rise higher and higher until they become real walls. This new method is quick, steady, and mesmerizing to watch. The robot follows pre-programmed commands that guide every curve and corner. Its nozzle moves with calm precision, laying one layer on top of another. Each pattern builds strength as it grows, forming a structure that is both beautiful and practical. There are no breaks, no mistakes from tired hands, and no delays from changing weather. The machine keeps moving until the shape is complete. These printers can create walls for small homes in only a few hours, with smooth edges and consistent thickness. The speed is a major advantage, especially in places recovering from storms, earthquakes, or fires. Instead of waiting weeks for safe shelter, families could have homes printed in days. This makes 3D printing a promising solution for emergency housing. Another exciting benefit is the freedom of design. Since the printer follows digital instructions, architects can create flowing shapes, rounded rooms, or unusual layouts without the cost of traditional methods. Curves that were once expensive and difficult now become simple lines of code. In the future, the machines may travel directly to disaster zones, printing walls on-site with portable equipment. This could bring hope to communities facing sudden loss, giving them strong, safe structures when they need them most. 3D concrete printing feels like a gentle blend of art and engineering, where a robot becomes a quiet builder shaping the homes of tomorrow. Number 1. Homes that float. Amphibious foundations present a gentle, practical, and almost graceful answer to rising waters. Instead of forcing a house to resist powerful floods, this system allows the home to move with the water, staying safe without breaking apart. The idea is simple but brilliant. During normal weather, the house sits on a stable platform that rests firmly on the ground. It looks like any ordinary home, but hidden beneath is a floating base designed to lift the house when water begins to rise. When flooding starts, the platform behaves like a quiet, steady boat. It carries the entire home upward, keeping it above danger, while everything around it gets soaked. Strong guiding poles stand beside the house to keep it in place. These poles make sure the home rises straight up, instead of drifting or tilting. When the floodwater finally begins to drop, the house follows the guides back down. It settles neatly into the same position it held before the storm. This smooth movement protects the structure, the furniture, and everything the family cherishes. Nothing crashes, nothing tears apart, and the home does not need major repairs after the flood passes. This technology brings enormous comfort to families living in regions where floods arrive often and with little warning. In areas near Louisiana, for example, storms have repeatedly filled neighborhoods with deep water. Many families once faced the fear of losing their homes every hurricane season. But with amphibious foundations, the story changes. Instead of watching their rooms fill with muddy water, they watch the house lift itself out of danger. Their memories, valuables, and daily routines remain safe, even during harsh weather. The benefits extend far beyond a single family's safety. When entire communities adopt this system, emergency stress drops sharply. People do not need to flee at the last moment or search for shelter far from home. Rescue teams are less overwhelmed because fewer families are trapped by rising water. Everyone can stay calmer, more secure, and more prepared. Amphibious homes show that engineering can protect both lives and emotions. They offer strength without force, safety without struggle, and hope without fear. As weather patterns grow more unpredictable, these floating foundations may become essential for communities across the world, helping them face the future with confidence rather than worry. If you enjoyed this video, like and subscribe, and also click the next video shown on your screen.